Okay, we've got section 7.5, one-to-one functions and inverse functions. Let's read this together. A relation is a function if it passes the vertical line test. That's review. We've done that for a long time. The special type of function is a one-to-one function. A one-to-one function is such that it passes the horizontal line test. So for each of these drawings here, let's answer the two questions. Do we have a function? Yes or no? And then do we have a one-to-one function after that? Look at this first curve right here. We can see that for a function, we will check the vertical line test. A vertical line would only intersect the curve one place at one point. That means that we would have a function, yes. For a one-to-one function, well, now we have to have any horizontal line only crossing a maximum of one place. Sadly, as we look right here, we have a horizontal line that crosses more than once. As soon as we see that, we know that it is not a one-to-one function. Take a look at the second picture. Is it a function? Well, a vertical line test can quickly be done. You can see a vertical line would only cross the curve at one point maximum. Taking a look at one-to-one functions, though, well, a horizontal line would cross more than once, so sadly we would say no. Remember, for each of these tests, for the vertical and the horizontal line test, as soon as you have more than one intersection for the line, you would not pass the test. Take a look at this line right here. A vertical line passing through this line would only intersect once, so is it a function? Yes. Finally, we have an example that no matter which horizontal line we are drawing in, we would only cross one time. So is this a one-to-one function? Yes. Now, one-to-one functions are very special. They help us know if an inverse of a function exists. The inverse of a function is going to be represented by f of -1 of x. It's read f inverse of x. The inverse of a function is really going to reverse the work that the other function has done, the original function. So the inverse of a function is the reversal of work for f of x. We'll talk more about that in due time, what it means to undo some of the mathematical work that we've been doing. Of course, there will be graphical connections as well. If a function has an inverse, it passes the horizontal line test. So to find the inverse of a function, we're going to do several things. Take a look at these examples right here. F of x really represents y. And if we're asked to find the inverse of a function, we're going to always switch x and y. We're going to switch x and y. Where we see y, we will replace it with an x. Where we had x, we will replace it for our y. And then we solve for the new y. So that's really what we're going to do for all of these problems. We switch x and y, and then we solve for our new y. In other words, get this new y alone. Get it by itself. And we've been doing this all year. You can see always deal with addition or subtraction tied to the variable first. We'd have x minus 4 is equal to 2y. Now you can see 2 is multiplied to y, so I will divide each individual term by 2. I'll have x over 2. 4 divided by 2 is a 2 itself. This is our inverse, but we're going to write it in a very specific way. Like we said, the notation is f -1 of x. Read f inverse of x is x over 2 minus 2. So what we're doing every time is we switch x and y, and then we solve for this new y. Take a look at number 2. F of x is just a y itself. So right now we need to switch x and y. Wherever we had a y, replace it with an x. Wherever we have an x, replace it with a y. What do we do now? Well, we have to get our y alone. And as always, deal with addition or subtraction first. We will have x minus 1 is equal to y to the third. Here's some fantastic review. When you want to get rid of a third power, we will take a cube root. So take the third root of both sides, and you can see then you will have y is equal to the cube root of x minus 1. Well, one final way we should write this, write it in the style of f inverse of x. That is the cube root of x minus 1. So, just finishing up these problems here, we've got example number 3. Y is equal to 2/5 x plus 3. What are we doing every time? Well, we are going to replace x and y. We're going to solve for our new y. But let's review something from way early in the year. The least common denominator in this problem is a 5. Let's multiply every part of the problem by 5. And that's actually a very smart thing to do. It's going to eliminate every fraction that we're going to encounter. You'll have 5x equals 2y. 5 times 3 is 15. So tell you what, we can subtract a 15 from both sides. We will have 5x minus 15 is equal to 2y. We will now divide everything by 2, and we will have 5 halves x minus 15 halves, and we could immediately write this as, instead of y, we could just say, you know what, we know that this is the inverse. We can write that as f inverse of x. The rest of the notes on the back page, honestly, are just more review. Let's take a peek at them very quickly. Are the following functions? If so, are they one-to-one functions? Well, for number 4, do we pass a vertical line test anywhere? Yes. Let's see, would we pass the horizontal line test? No, we wouldn't be one-to-one. That means we would not be able to find an inverse. Take a look at number 5 very quickly. Number 5, a vertical line would intersect more than once. We're not a function. That means immediately we can't be a special type of function. We don't even have to check the horizontal line test. One-to-one means that you must pass the vertical line test first. Take a look at number 6. We have a parabola, one of the most very famous curves in Chapter 5. Is it a function? Yes. Is it one-to-one? No. What does that mean? It means it doesn't have an inverse. So important for us to know that. We're going to see why in just a moment. Take a look at number 7. Is it a function? Why, yes, it is. One-to-one? No. No, it is not. Just real quickly addressing the last 3 problems, wanted to talk about, ironically, number 10 first. This is a parabola. We know this from Chapter 5. This parabola, of course, has a U-shape just like so. It would not pass the horizontal line test. This would be an indication of not having an inverse. Okay, let's quickly take a look at number 8, just getting some more practice. Y would equal 1/3 x minus 5. This is a line. Every line will have an inverse. We're going to just have to switch x and y. X is equal to 1/3 y minus 5. Tell you what, let's multiply everything by the least common denominator like we did at the bottom of the front page. We'll have 3x is equal to y minus 15. Very quickly, we could just add a 15 to both sides. We'll have 3x plus 15 is equal to y. Well, what is that really? Well, f inverse is equal to 3x plus 15. Let's take a look at number 9. Y is equal to 3x plus 12. We could switch x and y together. Wherever you see an x, replace it with a y, and vice versa. Now get y by itself, minus a 12 on both sides. So we have x minus 12 is equal to 3y. Divide everything by a 3. You will have x over 3 minus 4 is equal to y. But we could write that as f inverse of x equals x over 3 minus 4. Well, there's just one last problem on this page, and that's number 11. What you will read in the book is that if your functions are inverses, f of g of x will have to equal x. Now, originally I said that an inverse, of course, undoes the work that f of x does, and vice versa. So let's just say that we start with x, we do some work on it with g. F, if it's the inverse, will undo that work and will be right back where we started. So what we could do very quickly is go back to yesterday's lesson and say, let's evaluate f of g of x. Let's find f of g of x. So if we're going to do that, g of x, of course, is x minus 3. We're going to plug in x minus 3 in here. We're going to say, what is f of x minus 3? Now remember that for f of x, we'll have f of a blank equals blank plus 3. So you can see what we're really doing. We're plugging x minus 3 into that open space. We're going to plug that in as well right here. And what are we going to wind up with? Well, dropping the parentheses, negative 3 plus 3 is equal to x. That is, f of g of x equals x. Now, in all honesty, you're also going to have to show that g of f of x is the same exact thing, that g of f of x would equal x as well. So you have to show both. We're really not going to do this, but I did just want to address, at least here, what is happening. You're showing that f and g are doing opposite work. They're canceling each other out. So for f of x, you can see that's where we're going to have to start. F of x, we saw up above, is x plus 3. So we're going to say find g of x plus 3. Well, we know that g of a blank equals blank minus 3. So if we just hold on to this template here, plugging in x plus 3 into these blanks, we'd have x plus 3 right here, minus 3. Very quickly, you'll see that, yes, in fact, g of f of x equals x as well. So this is verification that they are inverses. Of course, you could have found the inverse of f and found it to be g and got that confirmation. Just switch x and y for f and solve as you did earlier. But this is going back to what inverses really are telling us, that the two functions undo the work that each individually perform. Well, we're going to continue talking about this. We're nearing the end of the chapter. Hope this is going well for you. Be sure to get extra help if you are having difficulty. Best of luck to you.